Example 7 says this: a force of 120 newtons is needed to push a box along a level road at a steady speed. You know what? I think maybe that's a really important word. What does that tell me? More specific, as a number, what's A exactly? So what else does that tell me? In terms of a free body diagram, the forces are, means no winner, it's a tie in the horizontal direction, and it's a tie in the vertical direction. If the force of gravity on the box is 250 newtons, A says, what's the force of friction between the box and the road? Dan, what's A want me to find? Any suggestions how I might want to start out? What might this be? A good job. I think let's do a free body diagram. Okay? And by the way, when don't I? Did it say a net force, a what force, a net? Probably then you won't be wrong to draw a free body diagram. So I'll put the box kind of over here off to the side. What are the forces acting on it, Dan, my friend? Get the obvious one. How big is gravity, by the way, exactly as a number? Look at the question. He's going to figure it out. We're waking Dan up. It's all good. I don't know. Read the sentence that starts with the word if. How big is the force of gravity exactly as a number? Keep reading. Read the sentence that says the word if. Starts with the word if. Second sentence. If the force of gravity on... Okay, you with us now? Sorry, you awake? Yeah? Okay. How big is the force of gravity exactly as a number? Good. So let's do that. I'm going to put in mg, but just because to remind myself I know it, I'll stick that on there just so I don't inadvertently, because yeah, Dan, you're right. You might miss that, or you might forget, or who knows for you. But yeah, right. Are we sinking into the ground like quicksand, Dan, my friend? Flying like Superman? So what force do I need to add? Good. How big is the normal force exactly as a number in this case? Gotta be. Okay. Is there friction? Oh, wait a minute. There's another force this question mentions. Can you read to me or read to yourself the first few words of the question? How hard are we pushing on this box? What do we call the mystery force coming from off the page, just so we don't always have to make up a dumb name? F applied. So there's definitely an F applied. What else? Which way? Bigger, smaller, or the same size as F applied? And how do I know? Yeah, why? Good. Dan, what did A want me to find? I don't need to go mu times the normal force. I know exactly how big friction is. How big is friction exactly as a number, everyone? Gotta be 120. Not 121, not 119. Must be 120. So I was all set to do the equation for friction, but actually no, it just tumbled right out of my free body diagram. Now it happens sometimes. Let's keep going, Dan. What's B want me to find? What is the? Hey, Dan, what's me? I don't know what's me with you. I think it wants me to find mu. What did I find in part A? Bet you I'm going to use that. Yeah, you've clued in that that's a trend quite often, right? Okay. Well, can anybody give me an equation that has a mu and friction in it? Yeah. Let's write that down. Dan, what did you say they're asking us to find? Which, by the way, why did I say kinetic friction? I did that rant last day about the difference between kinetic sliding and static at rest, but I also told you I'm not going to test you on it. This is me just being a physics nerd mod and saying I got to use the right words, because otherwise it's like fingernails on the blackboard to me. Okay, I want to get the mu by itself. What's the Fn doing to the mu, Dan, my friend? So, are you telling me that an equation for coefficient of friction is the force of friction divided by the normal force? Yes, it is. Oh, what is the force of friction exactly as a number? What is the normal force exactly as a number? Newton's first and a good free body diagram, Danica, and really this question fell apart. Now, yet again, Dan, I agree. You have to know your stuff, but really, 12 divided by 25. Can I do that in my head? Well, it's going to be a little less. 0.48. Yeah. Ooh, Dan, what are the units for the coefficient of friction? It's a trick question. You know how you can tell? What are the units for force? Newtons. What are the units for force? Newtons. You'd have newtons divided by newtons. Those would cancel. No unit. That's why there's no units. It's a ratio. Good job. So I would consider that fair game now. It looks really complicated. By the way, I kind of like questions that look really complicated, but then, oh, that really fell apart, because really we could almost have done that without a calculator except for the final step. Okay, next page. Cool. A dragster's tires accelerated from rest. I would probably mentally underline the phrase from rest to a speed of 48, distance of 64. I can definitely tell you, Danica, we're using some kinematics equations. I think we're going to be using the 4. Okay. Hey, Danica, what's A want me to find? Am I going to find it with forces? I don't think so. I think I got, you know what? A equals question mark, because what's from rest? Okay, you know, that's how I kind of clued in. I don't think I'm going to go winner minus loser equals MA. I'm not using finding acceleration using Nick's theorem. Also, I kind of read a bit further and I said, you know what? I'll bet you we're going to use the acceleration to find some forces stuff instead of using the forces stuff to find the acceleration. And I've told you, as far as I'm concerned, now that I've showed you formula manipulation, Raj, I can show you how to do a question in one direction. Hey, they gave me acceleration and said find the force. I'm also, as far as I'm concerned, it's fair game for me to give you the force and say find the acceleration, or vice versa. Okay? What did you say, Danica? VI is? What else? What else? And technically that's a displacement, but we're moving forward, so it's positive anyways, which is why we were so casual with distance and displacement until we did free fall and cliffs. Yeah. Which equation, Danica, my angel? Can you get the A by itself? Oh, you were. Sorry. Remember how tough that seemed a while ago, and now it's like boring. Okay, 48 squared minus 0 squared all over 2 times 64. I have no idea here.
Do this one in your head, Mr. Derek.
Well, actually, hang on. Because 48 is 16 times 3, so it's 9 times a pair of 16s. One of the 16s would cancel out. No, it's still yucky. Worked out evenly. I should have been able to do that in my head. I'm disappointed in me. 18? Units, Danica? Okay. Zach, what's B want me to find? The what force? The what force? If it says net force, what can I go straight to? Oh, okay. Did they give me M, Zach? What? Yeah. Did they give me A? No, but what did I find in part A? A. Uh, 9,720? Units, Zach? It's a force. Yep. Cool. Lena, what's C want me to find? C. C, not D. C. Okay. Now, my first thought, don't write this down, my first thought was to go, well, friction equals mu times the normal force. But Lena, you know, what did D want me to find? Do I know mu? So can I find the force of friction doing this? Okay. Any suggestions on this might be a good job. Now I might try, because now we're past net force. They're talking about friction. I might try a free body diagram. Let's do our free body diagram over here. Here's the dragster. What are the forces acting on it? Get the obvious one. Yep. What else? Normal force. What else? Which way is this dragster accelerating? Let's say forward, to the right. So which way should there be an arrow pointing? What force makes a dragster go forwards? Yes! I knew I could count on you. Again, though, folks, do you see how counterintuitive that is to somebody who doesn't have a physics background? What do you mean? No, friction is what slows things down. No, it's not. Not in this case. It can create motion, too. And you can see the temptation for somebody to say, no, isn't that F engine or F tires? No, no. Is there a force pointing backwards? If we ignore air resistance, and we are pretty much going to be doing that, unless the question says include air resistance, ignore air resistance. Okay. Hey, who's winning? Who's losing? What does winner minus loser always equal? More specific, do you know what winner minus loser equals in this case? That MA. In other words, my equation is going to be this. Oh, let's go black, Mr. Duke. You're changing colors. Winner, yes. No loser, because nothing's pointing to the left. Equals, and instead of MA, I'm just going to write 9,720. What were we trying to find in part C, Lena? What is the force? Done. Done. Yeah. No mu times and 1 done. That was kind of nice. Mud, what's D want me to find? What did I find in part C? I bet you I'm going to use my answer from C to do part D. In fact, I think it's going to be very similar to what we did in the last question. Is there an equation that has a mu in it? Say yes. Yeah. Get the mu by itself. If you feel comfortable, Taryn, going straight to that. In the previous question, I wrote this first, and then we got the mu by itself. If you're comfortable saying, well, I can get the mu by itself without rewriting it first because it's on my formula sheet, go ahead. Oh, Mutt, what is the force of friction? Ah, I don't know the normal force. Oh, but look. I know another force the same size as the normal force. Which one? Did they give me M? Yeah. What was it? Ah, okay. 9,000, that. Oh, I could have just hit answer button if I'd been really clever. Divided by bracket M G. Is that high? Dragsters have sticky tires because friction is what makes them go forward. Right, Zach? Not look at your phone or anything. No, that was your calculator. I apologize. Difficult sometimes now that phones have gotten big. It used to be phones were way smaller than calculators. Now it's, you know what? I'll bet you if you manufactured a smartphone that from the back looked just like a calculator so that kids could get away with using it in class, you might be able to, or a case that made your phone look like a calculator. I'll bet you there'd be none of you would ever want to look at your phones when I'm teaching instead of your calculator, right? You would never want to somehow disguise your phones. There wouldn't be a market for that among teenagers at all, would there? I just saw some of you that have 3D printers. Your minds are churning. Hey! Units? Oh, yeah, it's newtons over newtons. Okay. By the way, have I really taught you anything new yesterday or today? I hope not. I hope all I've done is shown you, I've given you tools. We can actually handle some pretty interesting stuff, I think. I like example 9. I like example 9. Example 9 is a nice question. Eric, why does example 9, what's weird about example 9? What makes you go, ooh, this is a tougher question. I better pay attention to this. Ding, 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 ding. Do you see it? What do you see? What's weird about this one, folks? Marcus, where's the extra force? This one. I've done stuff with forces sideways. But you know what? Eric, the normal force will not be mg. You know how I can tell? There's an extra vertical force. Okay? Eric, what does example 9 want me to find? Any thoughts on how I might want to start out? Yep. Oh, did they give me a picture? I'm going to label a picture. What are the forces acting on this, Eric? Get the obvious one. What else? Is the normal force here going to be bigger, smaller, or the same size? Oh, it's not going to be the same size. I can tell because there's an extra vertical force. Is the normal force here going to be bigger or smaller than mg, Eric, my friend? Why? Someone else is doing some lifting up already. I don't know who. I don't care who. All I know is something's pulling up with 85. The ground doesn't have to push up so hard. I'll really exaggerate it so it catches my eye. What else? Well, they labeled one for me. That 75 is what? Oh, got to pause the video for a second. What do I got? That 75, F applied. I'll draw an arrow on there just to remind myself I paid attention. What else, Eric? Which way? Bigger, smaller, or the same size as F applied? Read the question carefully. Read. Why? Which way are we accelerating? How can that be? We're slowing down. I'll really exaggerate it so it really catches my eye. Okay. Okay, Captain Smarty Pants. Who's winning? Ooh. Who's losing? Yep. What's that equal? Yep. And again, this is why at the beginning of this unit, Keegan, I said, I'm not giving you anything more than this. There's no way I can make up every single equation, because now this equation, we're going to start to customize it, and it's going to get really weird. First of all, Eric, what are we trying to find? Where is mu hidden in which of these? Let's get friction by itself first. Then I'll get the mu by itself. You follow that? How would I get friction by itself? I guess I need to move F applied over. Psst, psst, psst. If you do that, Zach, I'll know what you meant. On my next line, I think now, Eric, I'm going to bring in what friction actually is. So friction is what times what? Oh, I was going to write friction again. Mu times the normal force Okay, what am I trying to find? How would I get the mu by itself? Eric, do I know M? Sorry? Yep. Do I know A? Yep. Do I know F applied? I don't know the normal force. And I can't say so easily, oh, but look, I know another force the same size as a normal. You know what? I think over here, I'm going to write a vertical force equation. So, Eric, are we sinking into the ground like quicksand? Are we flying into the air like Superman? Then what can we say vertically? The forces must be, I'm looking for a word that starts with the letter B. Everything up has to equal everything. Give me an equation. Fn plus 85 equals mg. So if Fn plus 85 equals mg, what does Fn equal? If Fn plus 85 equals, get the Fn by, because you want the normal force by itself. Get the Fn. So what can I write instead of Fn? Mg minus 85. What can I replace this with? I've done this purely algebraically so far, Danica, just so you can see how it all fits together. Now let's start sticking in the numbers here. But this has to work. I've scrolled down, Eric. What was M? What was A? Do I need to make it negative because it's to the... No, we took care of that with our winner minus loser fact. We let to the left be positive because it made the math easier. And it does. Minus, what was F applied? All over 20 times 9.8 minus 85. I think definitely brackets around both the top and around the bottom, or fancy schmancy button. This is one you should all try typing in to see if you get the correct answer. I have no idea what the answer is, so I'm going to type this one in too. Did I make a typo?
Why did you do like plus F5?
Oh, why did I suddenly do a minus sign there for some dumb reason? Because I'm dumb? Because I make mistakes. I was the king of getting a 98 on a test. And for me, it was always, I was good on remembering units, but something like that. Yeah. So, thankfully, I listened to my physics teacher and I got a good calculator that lets me backspace and edit so I can fix that. Thank you, Mudd. I should have caught that, but thank you. I owe you a candy. Don't let me forget. Y'all get 0.8918. Is that right? Okay. That's high. Oh, no. You know what? That makes sense. It's sticky. How sticky? This is slowing down. Because we're pulling fairly hard, but it's still slowing down. This is really sticky. 0.892. Yes? Units. None. Is that okay? Mr. Dewick, don't write this down. Could I do that? Can you? Well, let's find out. So what you're saying is I should get the same answer without the 20s. Do I? No. When can you cancel? You can cancel when there's a 20 in, if there was a 20 there and a 20 there. If there was a 20 in all four things, then if you wanted to, you could say, I think they'll cancel out. Not here. Did I show you the balloon video already? Okay. So, what's your homework? I'm going to give you a lot of practice with this. It's a Friday, but I'm going to give you 40 minutes or so to work on this. So if you hustle, you won't have much homework, if any, for the weekend. So definitely number 1. Number 2. What's number 2 asking you to find? Tension. Is this sitting on a surface? Is that mass sitting on a surface? So is there a normal force? Don't get normal force loopy and start sticking them everywhere. If you're not on a surface, if you're dangling in midair, there is no surface pushing up on you, no normal force. But you're still going to probably do a free body diagram. Number 3 is so easy that it's tough. 4 is good. 5 is good. 6 is good. I'm probably going to assign almost all of them. 8, 9. Yep. 10 is good. Yeah, we'll give you all of them. Okay. I gave you all a printout so you can see what you're missing. Those of you that got here late, I'll get you your printout in a second. Those of you that got here late, I'm going to come and gently find out why you're late.